Alright, question number 2 says analyze the given table. So I noticed a couple things. I have x values. I have one function. S is a function of x. So this is one function. This is your second function. And then if I multiply the two functions, I get the third function called p of x. Okay? The question is, how many real zeros does p of x have? Well, some things that you can do is you can graph it, right? So I'm just going to graph x, just give myself a rough sketch. Can't use your graphing calculator. And -2, -1, 0, 1, 2. These are my x-axis and this is my y-axis. So what I'm going to do is I'm going to graph, the p of x values. And this will kind of give me an idea what's happening to the graph. I have -2, -3. So negative, negative. So left 2 down. And then, -2, 66. -66. -1, +7. So positive value now. 0, 10. So that's 10. That one's 7. 66. Kind of gives me an idea where my graph's going to be. Here, here, here. 163, so something way up there. 2, something way up there. And then 3, something way up there. So here's what my graph could look like. We're not sure if any other information's happening here. Not quite sure, right? We have an opportunity just to kind of like look through it. And just giving a graph kind of gives me an idea. But based on my basic graph, I noticed that how many times is it across the x-axis? Just once. That's a shoot through, right? That's an odd. So anytime it's crossing the x-axis, those are my real numbers, my real roots, they call them. Okay? So I notice it's going through, and it's an odd. So if I look at my real roots, these are evens, so it can't be those. And then it asks me how many imaginaries do I have there? Well, if I look at this equation, I can determine that we can go back and look at like s of x. You can look at your first common difference. Does that make sense? -4, +4. And we will recognize that this is a cubic, so your answer is B. So make a table of values, compare them, and you'll see.